So we are going to learn today about evidence for chemical changes. That means what are those, through observation, what are those evidence from that you can tell there is a chemical changes occurs or not. Okay, so whenever there is a reaction happen, gas bubbles, gas release or bubble formation, that's where you can say that chemical changes happen in that reaction. Light or release of heat energy. Whenever it's too hot, when you mix something and it's too hot or too cold, or release of light, that's where you can say chemical changes occur. Then third one is a permanent change, color change. If it is a permanent color change, then that's where you can say there is a chemical change. Alright, so these are evidences for chemical changes. Gas, bubbles, a gas release, light and release of heat, and permanent color change. So those are evidences for color, for chemical change. Alright, so next. Now, conservation of mass. Conservation of mass. What is that? So Antoine Lavoisier, he found that mass of reactants before a chemical change was always equal to the mass of the product. That is after a chemical change. That is after a chemical change. So before chemical change and after chemical change, mass of the reactants equals to mass of the products. So what that means? Matter is neither created nor destroyed in a chemical reaction. So you can't create matter, you can't destroy matter. It just transfers from one state to other state. So that's conservation of matter. Okay. Now let's take an example of conservation of mass. Okay. Let's say if we have, I'm going to go to next one. Alright. Now if we have 1 gram, 1.0 gram of hydrogen combines with 8.0 grams of oxygen. So that means 8 plus 1 you get 9 grams, right? So you expect that 9 grams of water is produced based on conservation of mass, right? Mass never created nor destroyed. Mass of the reactants before chemical change and after chemical change should be equal. Now let's look at another example. Okay, 3 grams of hydrogen combined with 24 grams of oxygen, then we can produce how many grams of water? So we can say, we can predict 24 plus 3, which is 27 grams of water we can produce. Okay. Now let's take another example. If 50.0 grams of water decompose to produce 45 grams of oxygen, now we need to find out how many grams of hydrogen produced. We have 50 grams total water, and when we decompose we get 45 grams of oxygen. So when we subtract, you can say there is a 5 grams of hydrogen we can produce. So by using that conservation of mass, you can find mass of product or reactants. Okay, let's take another example. Alright, if 2.43 grams of magnesium burns in presence of oxygen, to produce 4.03 grams of magnesium oxide. What is the mass of reacting oxygen? Now when you write in chemical equation, magnesium reacts with oxygen, it gives MgO, magnesium oxide. The mass of magnesium is 2.43 grams and we produce magnesium oxide 4.03 grams, and we need to find out the mass of oxygen. So let's say 2.43 X is a gram of oxygen and 4.03 gram is the total MgO. We need to find out the X. So X we can find 4.03 minus 2.43 and you get 1.60 grams of remaining oxygen gas that you can find. So that's you can apply law of